So here we're going to see how we decide which of our resonance structures are preferred. And in order to do that, we need to use something called formal charge. So what I'm going to do for each of these two molecules that we're going to look at, we're going to use OCN in the second example there. I'm just going to go back and get rid of that. I'm just going to put up the dot structures that we get to and then show you how to calculate the different formal charges so that we can determine which is preferred. So for carbon dioxide, we saw an example earlier that we have carbon, let me change colors there, carbon, single bond oxygen, double bond oxygen. We have carbon double bonded to both oxygens. And we have carbon triple bonded to the right, single bonded to the left. So for formal charge, what we do is we split all of the bonds in half. Half the electrons go to one atom, half the electrons go to the other atom. And then if there's any lone pairs, they belong to the atom that they sit on. So when we're calculating formal charge, what we need to do is take number of valence electrons that the atom normally has and subtract the number of electrons that we've assigned it using our formal charge assignments. So each of our oxygen normally has 6, so we're just going to write 6 minus for the carbon, 4 minus, 6 minus, 6 minus, 4 minus, 6 minus. We're just setting up our math here. Okay, and now what we're going to do is we're going to subtract the number of electrons that we have assigned each of these atoms. So on this oxygen atom to the left, on the very left structure, we've given it 1, 2, 3, 4, 5. So 6 minus 5, and that's equal to plus 1. For this carbon in the middle, we've given it 1, 2, 3, 4. So 4 minus 4 is equal to 0. And 6 minus 1, 2, 3, 4, 5, 6, 7. So we've got 6 minus 7, and that's equal to minus 1. So we've got a plus 1, a 0, and a minus 1 for the formal charges for that structure on the left. That's not too bad. Let's take a look at this middle structure. So for the left-hand oxygen, we've got 1, 2, 3, 4, 5, 6. So that's 6 minus 6, that's equal to 0. Got 1, 2, 3, 4 for that carbon. That's equal to 0. For this oxygen, we've got 1, 2, 3, 4, 5, 6. So 6 minus 6, that's equal to 0. So the structure with two double bonds gives a 0 formal charge for all the atoms, and that's the ideal situation. And what we'd find for the structure on the right is very similar to the one on the left. We would have 6 minus 7, 4 minus 4, 6 minus 5, and we'd have a minus 1, 0, and a plus 1. And so when we're assigning the most preferred structure, we get this one here because it has the formal charges closest to 0. Our next example is for OCN minus, and those atoms are bonded in that order. So we can write that up, and you can do the dot structures on your own and see that there's some different options there. But what we get to is a situation very similar to what we had for carbon dioxide, where we can have the oxygen triple bonded to the carbon, single bonded to the nitrogen. We can have the oxygen double bonded to the carbon, double bonded to the nitrogen. Or we can have the oxygen single bonded to the carbon. Make this a little longer, which is triple bonded to the nitrogen. Okay, and so now when we split our bonds here, split those, split that, split that, split that. And we start to assign our electrons here. Our oxygen would normally have 6, carbon would normally have 4, nitrogen normally have 5. So 6 minus, 4 minus, 5 minus, 6 minus, 4 minus, 5 minus. Okay, so in this atom we have oxygen with 1, 2, 3, 4, 5. So 6 minus 5 is equal to plus 1. Our carbon is 1, 2, 3, 4. 4 minus 4 is equal to a plus 1. I'm sorry, not equal to plus 1. Equal to 0. And then for nitrogen, we have 1, 2, 3, 4, 5, 6, 7. So 5 minus 7, which is equal to minus 2. And we can see that the sum of that is equal to minus 1, which is what we need to end up with since the overall charge is minus 1. Okay, so let's look at the middle one here. So for oxygen, we've got 1, 2, 3, 4, 5, 6. 6 minus 6 is equal to 0. We got 4 minus 1, 2, 3, 4. So 4 minus 4 is equal to 0. And then nitrogen, we have 1, 2, 3, 4, 5, 6. And that's equal to minus 1. Okay, that's looking a little bit better. We've got two structures at 0, or two atoms with a formal charge of 0 and one at a minus 1. So that's looking like a pretty good structure. But let's do this last one. And here we have oxygen with 1, 2, 3, 4, 5, 6, 7. So that's a minus 1. Carbon has 1, 2, 3, 4. That's equal to 0. And nitrogen with 1, 2, 3, 4, 5. So 5 minus 5, that's also equal to 0. So here we can see that we have two structures that have the same set of formal charges. Both of them have 2 zeros, and both of them have a minus 1. So the rule says that in order to see which of those is more preferred, you take the structure that has the negative formal charge on the more electronegative atom. And in this case, oxygen is more electronegative than nitrogen, which means that this structure is the more preferred structure.